Okay, so I'll start recording. So for today, meron tayong synchronous session. But this synchronous session, for those who would be listening to this asynchronously, hindi naman siya required, but it's encouraged, especially if you have questions that you want answered. If we would review our syllabus map, we're currently at week 2. We're in. You would be tasked to have a review of the important chemistry topics. So this is done asynchronously. So the materials were already uploaded in our OVLE. And an appreciation of metallurgical thermodynamics. So this is through your project. So tinignan ko, isa pa lang yung group na nagbibigay ng project nila. And of course, the discussion of the commonly thermoanalytical methods and how do we interpret them. So we've already given the materials. You can do this asynchronously. There are also a lot of references online that you can use in order to answer the worksheet. Pero yun, the purpose of this is the synchronous session is if you have questions or if you need any consultations, we can talk about them. So the first submission would be our ito yung worksheet number 1 natin. So for worksheet number 1, this is done in either pair or trio. For the submission, you have to submit individually pa rin. So parang you can have a shared folder or you can compare notes with your pair, sa pair lang ninyo. Then you have to submit it individually. And you have to write who was your pair for this particular worksheet. So for today's agenda, so number 1 is the review of the course materials in OVLE. So yung una-una is the laboratory safety and disaster risk preparedness and the access of restricted materials. So some of the materials would be restricted if you do not do the quiz. So it's very important to those who were listening na hindi pa nag-access ng quiz. So pakisagutan na lang yung quiz. Madali lang naman sila. So I think, tama ba? Kayong lahat na nandito is nakapag-answer na ng quiz. So thumbs up or check pag nakapag-answer na.
Yes po, ma'am.
Okay na po, ma'am. Nakapagsagot na po.
Yeah, so thank you. Before we go to the next, so meron lang akong konting, siguro itong 4 people natin joining would participate. We have a Slido moment ulit about some of the key considerations. And after that, yung consultation na natin with worksheet number 1. So I'll just be sharing a preview of the review on the chemistry topics that were shared and the review of thermoanalytical analysis and some instructions on the submissions. Tapos at this point, we can also have a Q&A portion. So if you have questions in particular for every problem, sana hindi naman sa problem 1 and 2 kasi madali lang naman sila. So I think mostly yung questions would be on the thermoanalytical techniques. Then lastly is small updates on the projects. Yan. So sa mga people na nag-a-attend, para naman may ending yung lab safety and disaster preparedness video natin. So kahit isa lang, I know that I asked you some of your key takeaways on the videos. Can you share in our synchronous session, what was your key takeaway in both the videos? So kahit very short lang. And the best way is the safest way. Oxygen feeds the fire. So that's a good key takeaway. Very specific. May dalawa pa na hindi nag-answer. Yeah, let's wait dun sa dalawa natin na participants. Safety can be done everywhere, so that's also a good answer. And if the chemical is unlabeled, consider it hazardous. Tama. The chemical is unlabeled, you have to consider it as hazardous. And siguro in relation to that, do not leave unlabeled chemicals. So I want to focus on this, yung the best way is the safest way. You can never go OA, yun yung term eh. Parang okay lang maging OA when it comes to safety because yun, you can never go OA when it comes to safety. Sana na-gets niyo siya. So welcome kay Mary for attending. Though meron pa nag-chat, don't eat in the lab, remain calm and assess the situation. So these are very good answers, especially when it comes to disaster preparedness. And we know that in our country, di ba, sobrang dami nating disasters na pwedeng sa atin. I think some of you are, or lahat ata kayo ay may NSTP ngayon. So sideway lang, one module is about disaster preparedness. So ayan, so I think we can move on. So thank you for those who joined and welcome sa mga kakadating lang. Ayan, so I have some infographics here about emergency preparedness, so for the workplace, but this can also be applied, di ba, in any place, may mga specific lang. So pwede rin sa inyo to, di ba, know the natural disaster shelter locations, so keep safety data sheets, some of the important parts. Ito matututunan nga ninyo sa mga nag-NSTP class, pero meron tayong map. Tapos alam ko, they have an app. I forgot the name of the app, but the app identifies kung saan ba yung mga disaster risk zones natin. So, yun, disaster risk pricing. So, we have to be prepared, diba? So, it's not a new concept. However, it's a new priority. And for us in the Philippines, I think we're being more serious when it comes to disaster preparedness. And ito, very important. So, of course, we have our lab safety rules. I know that we are not in the laboratory setup, but it's still important to know them so that when it becomes feasible for you to go to the laboratory, so kaya nyo pa rin siyang gawin. And the lab safety rules can also be applied at your own home. So kapag meron kayong mga fire, di ba? Kapag meron kayong chemical hazards, so they're very important. So why are they important? So of course, we want to minimize the adverse effects and exposure not only to chemicals but also to other equipment, hazardous equipment as well, if they are not maintained properly. And ito, nakita ko to, medyo maganda yung sinabi niya na a safe lab environment are dependent upon both you and your classmates. So when you go to the laboratory, the safety of the laboratory is actually highly dependent on you. So you have to practice you have to practice the safety rules. You have to work together to ensure the safety of yourself and those working around you. And you have to always follow the directions. So may miscut. Siguro siya yung lecture. So, and let's end yung review natin about disaster preparedness and lab safety. We now go to the chemistry review. So ito, hindi ko na siya i-review, but these are some important considerations that you have to know if you want to parang learn more or parang mas prepared ka sa physical chemistry or sa thermodynamics. So we have shared a video there. It's more of a preview then what are the important concepts or equations that you should know. So stoichiometry is very important. So in your MetE 17 and here in MetE 17.1, it's very important that you know how to balance your equations. Ano yung relationship ng isang reagent to the other reagent. So those are very important. Solution chemistry, which involves molarity, mole fractions, and molality, will also be used. We have experiments that would be asking you to compute for this. So, mahalaga na nare-refresh nyo sila. At saka hanggang sa dulo, kailangan nyo pa rin itong mga na to. Normality was given in the slides, but for us, medyo bihira. If I'm not mistaken. Meron pa rin, so it's also used in some examples, but bihira yung sa normality. Solubility equation, so ito yung mga dilution and relationship with molarity. So these are important when you prepare your reagents. So if you have computations on reagent calculations, so mahalaga sila. And some general chemical equations. So KSP natin, yung Q, etc. So there are a lot of Gen Chem na equations or Gen Chem na topics that would be useful when you go into thermodynamics. So before we proceed to the next, ito, wala na yung iba, but do you have any particular questions or meron bang hindi naiintindihan dito sa mga chemistry review natin? Wala naman, okay?
Wala naman po, ma'am.
Sige, sige. So, okay naman. So, okay tayo sa mga nandito. So, ayun, there are a lot. Yun yung maganda sa topic natin. Maraming online references that you can check if in case hindi nyo maintindihan yung mga topics natin. And so now we go to thermal analysis. So ito, let's just run through the different thermal analysis. So we have the table. This was also in your lecture wherein if you have a specific property that you want to test, you have this thermal techniques and meron silang abbreviation. So you have for mass, you have gravimetric or gravimetric. And for temperatures, ito, meron tayong thermal analysis, tapos you have for enthalpy. For us, ito, meron pa tayong mechanical properties, but these are mostly taught si TMA at CDMA. Mas tinuturo sila sa ME students, if I'm not mistaken. And actually, itong mga thermal methods natin, pwede silang i-apply sa metals, but mostly the applications are for polymers and ceramic materials. So mostly for polymer materials if you would review our references. So ano ba yung expectations natin sa thermal analysis curve? So you have your Y and it's always most of the time as a function of time or temperature pala. So it can be measured in terms of nasa baba natin is temperature, sometimes it's time, and you have your slope. So these are measured from your thermal analytical methods. You always have to expect na meron kang thermal analysis curve. So very important dito yung mga peaks, yung mga valleys. So ganun yung gagamitin natin when we would interpret them. Ayan. So ito yung common. These are the four that we would be teaching in class. Kapag mass, this is the TGA. Then you have for enthalpy, you use DSC. Si DSC at saka si DTA, medyo similar sila ng principles, pero iba lang yung measure. DTA measures the change in temperature, while DSC measures yung heat flow or heat flow into or out of your sample as a function of time and temperature. And your TMA naman, it measures the change of dimension of your test specimens when heat and cool. Sige nga, before we review, kapag TMA, ano yung na-measure natin? Ano yung material constant na na-measure natin? Mag-raise ba ng hand? Yes, Jimwell. What material constant or material property can we get when we do TMA?
Hindi po ako sure pero siguro po creep po.
Creep? Pwede ba ang creep? Medyo iba ata yung test for creep eh. Ito ang sabi measures the change in dimension when it's heat or cool. Ano ba yung material property na nagsasabi sa atin? How well a material expands or extracts or compresses when subjected to heating or cooling. Alpha, yun yung ano niya, alpha usually. What is alpha? Sirit na. Do you remember ko? Ayan, may nag-chat. So may nag-chat. Fatigue, hindi rin. Do you remember coefficient of thermal expansion? So yun, if you want to know the coefficient of thermal expansion, TMA is one of the method. Meron pang iba. I'm not really sure if it measures fatigue. Kasi ang alam ko measurement ng fatigue, iba siya eh. Hindi siya change in dimension eh. Parang cycle testing. Then for DTA and for DSC, so ito yung changes in temperature natin. And we know that chemical reactions are related with change in temperatures. Sa DSC in particular, malalaman natin if exothermic ba or endothermic yung mga reactions natin. And lastly, for TGA, ganun din. We can determine yung decomposition ng mga materials natin. So very important sila. So ito, let's run through them. Hindi ko napapakita lahat, pati kung paano sila nag-work. But what can TGA tell you? Nag-MetE 19 na ba kayo ngayon? Are you taking kinetics?
Hindi pa po, ma'am.
No po, ma'am.
So, next sem pa. Tama? So, usually nga ata, nauuna ang thermodynamics before kinetics because in thermodynamics, it tells us how, di ba, parang usually it tells us how spontaneous a reaction is or if the reaction would proceed. Di ba? That's what thermodynamics tells us. But thermodynamics does not tell us if the reaction would proceed now or in a long time. So, example, correct me if I'm wrong, pero ang alam kong isang example is yung formation of diamond. The formation of diamond is a spontaneous na reaction, but it would take a lot of time. Ay, hindi ko sure to ha, yung sa diamond. I forgot na. But there are reactions like that na it's spontaneous, but it would take a lot of time for you to know if the reaction would proceed or not. So those of the parang use of your TGA is it can determine the decomposition kinetics and reaction kinetics of your sample. So additionally, yun nga yung sabi natin, diba? The term is decomposition. So it can tell you if your material is thermally or oxidative na stable siya at saka yung life estimate of your product. And if it's made up of multiple components. So these are some of the applications. And these are the graph interpretations. So ano ba yung graph interpretations natin? So you have your number 1, so no information obtained, so it may be stable at over the different temperature range. Yung number 2 natin, sorry tayo po pala to. So yung number 2 natin, nag-start siya sa taas, tapos bigla siyang bumaba. So meaning there's a rapid initial mass loss or desorption or drying. So ganun nyo lang siya ini-interpret. Kapag number 3 naman, you have decomposition in a single stage. Yung difference naman niya sa number 4, multi-stage na yung decomposition. And if you would compare, diba, ito, decomposition single stage, nakikita niyo ba yung cursor?
Yes, ma'am.
Yes po, ma'am.
So ito, decomposition multi-stage, and if you would look, may plateau siya, diba? So we can say na meron siyang stable na phases na napuform habang nagde-decompose siya. Unlike yung susunod natin, which is number 5, you also have multi-stage decomposition pero wala kang stable na intermediates. Kasi wala kang parang region na magsa-stable siya at that point or magpa-plateau siya. Ito is usually increase in mass. So one possible na reason is the oxidation of your metal samples. So, kapag nirarun natin yung metal samples, your TGA can also be used to know when your metal oxidizes. Kaya lang, if I'm not mistaken, hindi siya masyadong ginagamit kasi some of those oxidation of your metals, they can be very exothermic or pwedeng combustible din siya. So, bihira din. Sometimes, kapag sure ka na magde-decompose siya, tapos ang nangyari is na-read mo sa graph na pataas. So, meaning may mali dun sa analysis mo. So, you have to repeat again. So ito, quick ano lang sa inyo, if you want to check, compare the molecular weight of Fe at saka Fe2O3. So definitely, mas mabigat yung oxide form natin kesa dun sa pure metals lang natin. And last is production of oxidation leads to increase in mass which decomposes again. So ayan. So, parang ganito siya. Tapos, nag-combine sila nitong number 2. So bumaba siya ulit. So, nag-decompose ulit. Ibig sabihin, there are certain temperatures na stable lang yung oxide mo. Kapag beyond that, hindi na siya stable. So, ito yung ito yung very important for the interpretation of your TGA. Aside from qualitative na importance niya, so importante din minsan yung mga values. So, you can note what are the temperatures wherein it decomposes, ano yung percent decomposition niya. So some of the data that you can get from your TGA analysis. Okay ba? Malinaw ba yung sa TGA? May questions? Wala?
Ma'am, clear ko lang po. Yung
Sige.
mass po yung bumababa habang habang tumataas yung temperature. Tama po ba? Kaya po papunta sa right yung temperature.
Ito, increasing temperature to. Ito yung mass natin. So, yung mass mo is mataas siya sa, pababa yung mass. So, ito, diba, ang nangyayari sa kanya, it starts from this initial mass. Tumaas siya kasi pwedeng nagkaroon ng oxidation. Then, bumaba siya ulit. Ibig sabihin, nag-decompose din yung na-form na oxides. So, your mass is decreasing yung order. So, pataas. Tama naman yung arrow, pataas. Yung temperature din natin pataas. Ano to ha? Illustrative example lang. Ito yung mas usually na nakikita natin na data. So, itong pinapakita natin na ito yung possible na parang these are the basic na combination of what you can expect from a TGA na graph. So, kung ano yung mga usual na makikita ninyo, so ito yung example. So, meron tayong dalawa. Una is weight percent lang. Pangalawa is you have derivative of the weight percent. So, for the weight percent, so siya yung pinakita natin kanina. Ito pala. So, siya yung pinakita natin kanina na example. So, you have this. Ang interpretation niya, it's number 4. Meaning, you have a multi-stage na decomposition. May nagre-raise hand. Yes, Junwal.
I-clear ko lang po. Bale po yung makikita lang po na event po sa TGA curve is yung thermal decomposition lang po. Tama po ba, ma'am?
Yung weight changes niya, siguro mas general yung sagot na yung weight changes niya with respect to increasing temperature.
Okay po. Thank you po.
So, yung decomposition, it would depend on the graph, di ba? Masasabi natin na it's a decomposition or weight loss kapag weight loss yung nangyayari. Kapag weight gain, there's a possible na oxidation.
Okay po.
So aside from the weight percent, yung isa din na pwede nating makita is the derivative weight percent or ito yung percent change with respect to temperature. So ito yung usually na nire-report. Ito is either interpreted pero minsan built-in na ata siya dun sa software na iprepresent niya rin to. So yung derivative of weight change, di ba? Sabi natin, nagkaroon ka ng weight change at 100, around 100. Yung change na yon is, ang rate ng change na is at this percent, around 0.2% for every ganito. So ganun lang yung interpretation sa kanya. So we can say na at this point, at this stage, mas malaki yung percent change as compared dun sa percent change at this point. So meaning, yung rate ng reaction natin at this temperature range or at this stage is faster as compared dun sa first stage natin. Nasundan ba? Okay. Sige, may questions ba dito sa weight percent at sa derivative weight percent?
None na po, ma'am.
Wala na, sige. Ang crucial lang din dito is parang this data is very highly dependent on the parameters that you use when you do the TGA analysis. So kapag iba na yung parang, kasi yung temperature change mo rin pala, may ano to ha, parang 20 degrees Celsius per time or per minute. Hindi ko na maalala, depende sa parang nagtetest or sa standards or sa ASTM methods. But usually yun nga, kung iba yung gagamitin mo na rate of heating or rate of heating, so iba din yung expected natin na graph. So it's very dependent on the parameters that is used during the testing. So kung magre-report kayo ng TGA or any thermal analytical methods, kailangan nakaspecify kung ano yung parameters na ginamit mo. And I think that was the reason why dun sa worksheet natin, diba, naka-specify ano yung ginamit nila na test parameters. Okay, so yun na si TGA. The next is your DSC or differential scanning calorimetry. So ano nga ulit yung na-measure ng DSC? Kung sa thermogravimetric, it's usually based on mass. How about for your DSC? Okay, pwede kayong mag-chat na answer. You can also unmute yourselves. Okay, so may nag-chat na heat flow or enthalpy. So you can measure the heat flow or the enthalpy of the reaction. For this particular example, yun nga, we have this ano ba? Material property din to or material constants, which is mostly applicable for plastics. So ito yung BSE, mostly applicable for plastics because yung temperature, diba, if you read the techniques, medyo limited lang din siya sa temperature. And some of our metals, diba, they can go way above this temperature para matest natin sila. So I'm not sure if some of the metals can be applicable, but I'm definitely sure na mostly ang ginagamit for this is for ceramics and for polymers as well. So you have your glass transition, melting and boiling, crystallization, percent crystallinity, heat fusion, and specific heat. Quick question, meron kayong MetE 11 ngayon? Tama ba?
Yes po, ma'am.
Okay. Nasaan na kayo sa MetE 11? Nag-discuss na ba kayo ng mga phase transformations, crystallization?
Yung sa part po siguro nung parang crystallography po.
May slide. Okay.
Opo, may
Oo, siguro mas ma-appreciate nyo rin to kapag pumunta na kayo dun sa part na yun ng MetE 11. So additionally, it can also measure the reaction kinetics, yung purity ng samples natin, and phase changes and polymerization. Polymerization is something applicable to plastics. So ano ba yung applications nito? Ayan. So yun lang din. Phase diagram determination, physical aging, heat capacity determination, etc. So ano ba yung usual na nakikita natin na graphs? So una, tingnan muna natin yung reminder. Sabi niya, not all curves can be seen in one thermoanalytical curve. So meaning, may temperature parang ito yung nangyayari, pero pwedeng may isa ka pang parang temperature na curve. So in order for you to appreciate this, dapat alam mo rin yung stages that the material undergoes under. So itong example natin, this is usually for polymers, for polymeric materials. So ano ba yung nangyayari sa kanya? Before we start, so we have heat flow. Kapag pataas, meaning there's an exothermic na reaction. So exothermic meaning heat is released. Kapag pababa, meaning there is endothermic reaction. So endothermic heat is absorbed. Okay? So, for the first, meron kang glass transition. So, there would be a shift of baseline due to the change in heat capacity. So, nag-absorb siya ng heat kasi yung glass transition is from hard to flexible state. So, para mag-transition siya, di ba? Para maging, next topic na ba pala? Okay, next topic na yung polymer. Okay, so baka madidiscuss sa inyo itong mga terms na to. So, in glass transition, what happens is, di ba? I think na-discuss to with regards to breaking bonds. In order for you to break bonds, you have to absorb energy, di ba? And energy can be in the form of heat. So ganito yung glass transition temperature niya. For it to be hard, to be formed into a flexible na state, so kailangan niyang mag-absorb ng energy. Okay, malinaw ba yun yung first stage natin? The next stage is crystallization. So for crystallization naman, ang mangyayari is it would release heat, meaning it's an exothermic process. Because in crystallization, your materials will actually arrange. So yung sa arrangement ng mga materials natin, it releases your heat. After that, magme-melt na siya. So para mag-melt siya, so same principle ng glass transition stage, ang mangyayari is it would absorb heat so that yung parang nag-rearrange ng materials mo is magsusoften siya. So in order for it to soften, mag-absorb ulit siya. So that would be an endothermic process. Curing or cross-linking is another form of your material to arrange themselves. So magkakaroon siya ng molecular arrangement. So it's also an exothermic process. And last na is your oxidation. So your oxidation, kapag oxidation, it releases heat. Kapag decomposition, it absorbs heat. So, kasi diba, para mag-decompose siya, so mag-absorb siya ng heat. So decomposition or oxidation, so it's either absorbs or releases yung heat natin. So ganun lang yung interpretation natin for a typical na DSC transition. Okay, so next is your DTA. So halos parehas lang yung interpretation natin for your DSC and your DTA. But the difference is kung dito ang minimeasure natin yung heat flow, kapag DTA, ang minimeasure natin is change or difference in temperature. So between a sample and a reference sample. So may ira-run ka, sabay yung unknown sample mo at saka yung known sample mo. So ira-run mo sila, kasi compare mo yung response ng unknown sample mo dun sa reference or standard na sample. So similarly, kapag pataas, it's also an exothermic process. Kapag pababa, it's an endothermic process. And kapag ganito yung transition natin, dito yung masasabi natin na meron kang change in heat capacity. Kapag yung peak niya is parang stepwise, unlike ito na, yung tawag sa ganitong curve. Unlike this curve, so ito may stepwise ka. Dito, ito yon. So parang pwedeng example is yung last transition natin. So nag-change yung specific heat capacity mo. Okay, so last is, may nakita din ako graphic. This analysis, thermal analysis in general, also tells us yung stability ng samples natin. Balikan ko lang to. So halimbawa ito, di ba? Nakita nyo tong green. Kapag nag-shift siya to the left, meaning mas nandito siya, less stable yung material natin sa decomposition as compared dun sa nasa green. Kasi yon mas madali siyang mag-change in percent weight at a given temperature. So ganun, i-apply din natin siya dito. So kapag nag-shift siya, ibig sabihin it's less stable to changes as compared to the other material. So last na is the thermoanalytical. So this measures the change in dimension and it's widely used to measure the coefficient of thermal expansion or the stress-strain behavior of your material. So ang graph natin is MPE, which is stress as compared to your temperature. So kung ano yung maximum na stress na ma-achieve ng material natin or optimum na stress or mechanical property ng material natin at different temperatures. So malalaman natin yung compatibility ng materials. So halimbawa, at this particular material, tingnan nyo yung, ano madaling tingnan, yung black. So let's look at the black material. From our black material, so at increasing temperature, we know na mas mataas yung kaya niyang ma-receive na stress. But at increasing, so bumababa na yung capacity ng mga materials natin. So ganun lang siya, yung suitability ng materials natin at different temperatures. Okay, so may questions ba dun sa akat?
Wala naman.
None so far.
Wala. So sure kayong malinaw yung explanation natin ng apat, ha? So to summarize everything, so we've mentioned 4 techniques. So unang-una is your thermogravimetric. From the keyword na gravimetric, it measures the mass or the change in weight of your sample as it is heated or cooled in a furnace. Enthalpy, on the other hand, is measured through DSC or differential scanning calorimetry. So this measures the heat flow into or out of the sample as a function of time and temperature. And you have your DTA for temperature changes. So, and lastly, yung thermomechanical analysis natin, which is used for mechanical properties. So, measure the change of dimension of a test specimen when heated or cooled. So, madali lang naman silang ma-identify. Ayan. Okay, so sure walang questions sa method. So, now we go to the second to the last agenda for today. So this would be the consultation for worksheet. So papakita ko lang yung problem set, and again, just to remind everyone, the submission is by pair, but you have to submit individually. Ano yung ibig sabihin nun? You can work with your pair. So pwedeng parehas kayo ng output ng pair ninyo, pero kailangan yung isubmit pa rin individually individually yung paper para lang may record din kami na nag-submit kayo. And ano pa yun? Please write the name of your group mates when you do this. And if you have references, please indicate them as well in your submission. May nag-raise ng hand kanina. Parang na-lower na ata.
Itatanong ko lang po sana kung pwede yung same na same kasi po by pair siya. So, tatanong ko lang po sana kung pwede yung same. Okay
lang. Basta, pag sinubmit nyo kailangan nandun yung pangalan ninyo parehas ng person na yon. So, kunwari kung sinong ka-pair mo, hindi to group this is pair or trio. So, kung sino yung ka-pair or ka-group mo, just indicate the name of your pair and your group. Okay ba? The worksheet should be handwritten para lang dito, kapag kailangan ng interpretation or computation, it should be handwritten. But if you have to graph it using Excel, so nag-share naman kami ni Sir Gabs ninyo ng parang worksheet, answer sheet. So pwedeng yun, i-paste nyo lang doon yung mga graphs or illustration ninyo. So tama naman, no? Wala naman kayong question siguro sa problem 1 and problem 2. Wala naman.
Wala po, ma'am.
Madali lang to si problem. Parang 1 step or 2 step lang ata parehas. Okay, so the next is for problem 3. So for problem 3, this is what would make you unique from the other groups as well. Diba? Pwede kayong magkaroon siguro ng similar paper, but definitely iba yung magiging interpretation or on how you would present the papers. So you have to find a research paper that use a minimum of 2 thermal analysis techniques and give the following. So title and author of the paper, ano yung thermal analysis na ginamit niya, ano yung test conditions, tapos ano yung mga images, and a short description of the interpretation of the images or diagrams. So halimbawa, may nakita kayong parang ganito na ginamit niya for testing, tapos mayroon siyang interpretation. So, summarize, lagay nyo lang si MG4 was found to be ganito as compared to MG1 because of blah, blah, blah. So, ganun din dito. So, the temperature found is letter C, temperature for this material, meaning yung material na to, hindi mo siya pwedeng gamitin sa ganito, ganito, etc. So, mga ganun lang yung expectations natin for worksheet number 2. Ayan. Yung next na is, I think dito ata kayo may questions. Tama ba? Okay.
Yes,
Sige. Ano yung questions muna before I preview ano may expectations dito? Click muna natin yung results. Na-access niyo ba lahat yung links?
Yes, pa.
Ayan. So, meron tayong tables dito, di ba? Yung table natin, yung worksheet natin, it consists of 2 sheets. Tama ba? Hindi pa siya nag-load. So, meron tayong TGA for a polymer mixture. Then, we also have DSC of the polymer mixture. So, in order for you to answer this worksheet, you just have to follow kung ano ba yung instructions. So, yung una, compute for the weight % of the sample by dividing the values of weight with the original weight of the sample. The original weight of the sample is given in the PDF na worksheet. Tama? Nakalist ata siya doon. So you just have to divide it. Then, you are tasked to plot the weight versus the temperature where the former is in the ordinate and the latter is in the abscissa to produce the TGA graph. So ano ba yung expected na output ninyo for this? It would just be something like this, yung kulay green lang. Okay? The third step is to, after observing the graph, wait lang. Yeah. So the third step, so after observing the graph, you compare it dun sa interpretation. Ano ba yung interpretation nyo dito? Ito yung pinresent ko kanina. Yung nasa slides. Tapos, based sa itsura ng graph niyo, sabihin niyo lang saan siya nagpo-fall under. Is it a single step? Is it a multiple step na stable? Is it multiple step unstable? So, yun lang si letter C. Then letter D, how many stages? So, it's up for you to interpret how many stages at saka ano yung temperature ng stages na yun. Yes, Jumel.
Ma'am, yung temperatures po ba yung temperature lang po kung saan nagsimula yung decomposition or yung range po kung saan nangyari yung decomposition po?
The temperature is the temperature where the transition occurs. Pwede rin, sige, nagigets ko yung question, no? Kasi pwede, di ba, ang sasabihin mo, it's the range from this temperature to this temperature. Wait lang. Sige. Temperature range na lang. So, kunwari, what comprises, ano to? How many stages? So, sasabihin nyo, kunwari, apat na stages. Ano yung temperature range? So, from 100 to 200, yun si stage 1. From 200 to 300, yun si stage 2. So, kahit ganun na lang yung answer ninyo.
Another question po.
Ay, sige.
Yung
Arthur, sagutin ko muna si Junwell.
ano po, yung estimation lang po ba namin kung ano pong temperatures yung kung saan nangyari yung decomposition or may computation po na gagawin?
You can do estimation, but there is a fixed answer because di ba, parang if you would look at the graph that you would create, makikita nyo na parang may tolerance naman tayo, but kapag sobrang layo niya, kasi makikita nyo yun on the graph itself, hindi pala graph, on the table itself, makikita niyo yung transition, tama ba? Pag meron siyang steep na transition, so it can help you identify ano ba yung temperature na yun. Na-gets ka? Sige, Arthur, ano yun?
Yung ginamit po namin for yung pag-determine ng temperature, ma'am, is ginaf namin yung gawa kami ng separate graph ng temperature versus yung derived na rate. Tapos pwede po ba gamitin yung mga peak ng graph na yun?
Pwede rin, actually, to determine yung transition point. Kasi if you would look here, balikan natin ha. So if you would look here, di ba, parang at this point, it slightly coincides ito. Pero may konting ano pa rin So at this point, it lightly coincides this range. So kailangan alam natin parang kung paano siya identify. So may tolerance naman. Hindi naman siya absolute values, but your answer should be near kung ano yung estimate. Kasi I think etong binigay
na
sa
gamitin
Gab is
namin,
answer
ma'am.
na. Pwede rin.
So pwede po yung mga peak ng graph na yun.
Pwede.
Okay. Thank you.
Pero dapat alam niyo ha kung where does the stage ends.
Okay pa. Thank you.
Sige. What else? So sa TGA, ano pa ba yung question sa TGA? How many stages? So kaya nyo na yan. Based only on the graph generated, make a hypothesis on what possible thermal event. So ito, I think you can already answer this based on what was written on the slides. And doon din sa mga masa-search ninyo na references. Ano ba yung possible na nangyayari doon sa stage na yun? So sabi niya from 24 to 650. So kung may makover siya na 2 or 3 stages, kailangan masabi ninyo kung ano yung 2 or 3 stages na yun. Okay? So ito lang yung pinakita natin kanina. Ito, ano bang nangyari? Pero mas magiging specific na siya. Kasi itong pinakita natin kanina, it's mostly, di ba? So desorption or drying. So pwede pa rin siyang possible na answer. Tapos pwedeng multi-stage decomposition. Ano yung nangyari? Pwede nyo siyang i-relate actually dito. Pwedeng ganito din yung answer ninyo. Or something like this. Okay, so yun yung sa TGA. So may questions ba kayo sa TGA? Wala na? So the next part, ay sige, go ahead Hans.
Na-chat ko po to. So,
Ay,
ulitin ko na
sorry.
po.
Wait lang,
Yung sa
naka-hide yung chat ko.
compute for the list weight percent po, kailangan po ba magpasa ng Excel file for that? Hindi na.
No need, but kasi yung sa worksheet natin, sige, pakita ko lang yung answer sheet ha. Yung sa answer sheet natin, di ba gagawin nyo siya sa Excel, yung calculation? You can paste the relevant graphs sa answer sheet na lang.
So yung graph lang po yung kailangan. Hindi na po yung table mismo.
Diba? Wait, double check ko ulit yung ginawang answer sheet. Baka mali pa lang sinasabi ko. Nakita niyo ba to? So sa problem 1, handwritten solution. So sa problem 2, sa problem 3, so sasagutan niyo lang siya. So yung images. Ito na yung problem 4. So problem 4, I think you can just insert the graph. Pati sa problem, ano to? Problem 4A and problem 4B.
Okay. Thank you po.
Kasi ang haba if masipag kayo, you can also insert the table. Pero, ano din parang pwede sigurong screenshot. What you can do is, for proof lang na ginawa nyo talaga siya. You can screenshot yung, kunwari Excel. So, baka magpakita ko yung Excel. Nasaan siya? Dito. So, kunwari ito, tapos may table lang kayo. So, you can screenshot this na lang. So, pwedeng ganun naman yung gawin ninyo. Okay na ba yun, Hans?
Okay lang. Pero okay lang kahit yung graph
Oo,
lang.
okay lang
talaga.
kahit yung graph lang.
Okay.
The next is yun nga, so ipaplot mo lang siya. If you can also show your interpretation, like example, kunwari stages, pwedeng lagyan nyo lang ng ganito. A to B or B to C, or parang stage 1 is from A to this point. Stage 2 is from this point to this point. So pwedeng ganun din yung gawin niyo sa graph niyo. The third is how many curves or thermal events. So same lang din siya. And make a hypothesis. So you just have to follow this, and yun, parang yung interpretation, you can look for reference, and actually yung nasa slides natin would be enough in order for you to answer kung ano ba yung mga possible na nangyayari. Yan. May questions ba kayo sa worksheet? So the deadline of the worksheet is October. Wait lang. Anong schedule niya nung sa atin? Hindi. Dito ba? Hindi. Ayun ha, reminders ulit sa mga hindi pa nagsasagot ng quiz. Parang 26 pa lang yung attempts. Hindi ko alam kung ilan yung total ng class natin at sa class ni Sir Labs. So, we are here. Ang deadline sa atin ay October 5. So, that will be tomorrow at 11:59 p.m. Yes, Loris.
Ma'am, may tanong po, if ever po ba, okay lang po ba ipa-extend yung deadline ng 1 day more or 2 days more po?
What's the reason?
Mostly po filed up deadlines lang din po. Tapos po medyo heavy worksheets din po.
Sige, kausapin ko si Sir Gabs. Kasi if we would, ngayon, ano to parang we would move our deadline. So, pwede yun 1 day or 2 days. Kausapin ko si Sir Gab kasi pag ganun, mag-move din sila ng deadlines. So, I'll talk to him.
Okay lang, if ever po ma'am, okay lang po na magpa-extend. Okay, and including po yung kabilang class din po.
Oo. Kasi magiging ano yun dapat eh.
Opo.
We can extend siguro one day. So, October 6. Kasi I think ito, parang may direction na naman kayo with the worksheets, di ba? So, you just have to answer them. Madali lang si worksheet 1 and 2. Si problem 1 and 2. Si problem 3, medyo mas matrabaho lang siya ng konti because you have to search for references. Then, si 4, basta ma-plot ninyo siya. So, yung interpretation na lang yung parang crucial doon. So, yeah, we can extend for 1 day. October 6.
11:59 PM pa rin po ma'am.
Oo, 11:59. Pero yun din, parang gusto nga sana namin wag na mag-11:59. Pero sige, for the submission, since yun nasa syllabus na din, I'll chat Sir Gab, we can extend for 1 day.
Thank you po ma'am, thank you po.
What else? Okay, so okay na tayo dito ha. So yung last part na natin, sige, go ahead Hans.
Minor na tanong lang po. Sa pledge po, kailangan po ba ng signature overlay?
Yes,
Or
and the pledge should be handwritten for both.
okay, so kailangan po siya.
Pledge ha, oo. Kailangan yung pledge, tapos i-handwrite nyo siya, hindi pwede yung naka-type, tapos pipirma lang kayo. So it should be handwritten. Picturean nyo na lang, tapos paste nyo na lang siya. Yes, Arthur.
Ma'am, last question ko po, ma'am. Sa differential scanning calorimetry po, ano po yung minimin ng negative values sa unobstructed heat flow?
Ano ulit? Ano yung kung bakit mo siya i-negate?
I mean, what do you mean with negative values?
Ay, kapag negative, kasi di ba kapag negative yung heat flow natin, so meaning, wait lang ha, plot is negative values versus temperature. Check ko lang ulit. Sa DSC, I think this is in regards with the reference eh. Yung sa reference na material na ginamit mo. Oo. For this case kasi, di ba, you start at yung na-record mo na unsubtracted na heat flow, that would be a positive value. Tapos ang gagawin mo is in-negate mo siya. Kapag ni-negate mo na siya, yung heat flow mo, this is in reference with yung purpose ng paggawa nun. In reference nga siya dun sa standard material na ginamit mo. So, kaya mo siya i-negate para kapag pinlot mo siya, yung magiging plot mo would show your ups and your downs, which is your exothermic and your endothermic.
So, in reference po siya, negative in reference sa given sa worksheet po.
So, kaya negative. Pero yun, dahil negative nga siya, so ganun pa rin, yung tingin natin, yung lahat ng nasa taas is exothermic, yung lahat ng nasa baba would be endothermic.
Okay, thank you so much, ma'am.
Yes, Loris.
Question lang po ma'am, can it be digitally handwritten po? Like digital?
Yung solution.
Opo.
Okay lang, yung meron kang drawing pad or tablet, tama ba?
Opo, parang ganun po. For the pair po.
Okay lang yun. Basta hindi siya yung, kasi diba, some of the solutions, tinatype siyang ABC. Kasi para lang din ma-practice ninyo na parang sinusolve siya.
Ano po naman, mostly po i-write po mismo. Written talaga ba?
Oo. Okay lang yun.
For the parents po. Yun,
handwritten pa rin naman siya, di ba? Handwritten pa rin naman siya. So, okay lang.
Thank you po. Ay, ma'am, pati po pala yung pirma, if ever po.
Okay lang yun.
Thank you po.
Ano pa? May questions pa ba? Hans, may nag-chat. Sandali, check ko muna yung chat. On any paper naman po. Yes, on any paper pwede yung pledge. So, yellow paper, notebook, index.
Ma'am, last na talaga. Yung dito po sa may difficult po, hindi na po to handwritten na po. Ano na po to? Pwede na pong typewritten?
I think so. Wala namang instruction. Parang okay lang naman.
Ang i-handwritten po is yung sa easy po and
Yung,
sa average.
yung may solutions. Yan, yung dalawa.
Thank you po. Thank you, ma'am.
Ito, hindi rin, no? Pwedeng typewritten lang din, no? Basta pakita nyo interpretation siya. Yan yung mas mahalaga na part. Ano pa ba? Wala na, I think. Wala na, di ba? Ito na. So, punta na tayo dito. So, our worksheet would be moved for 1 day. So, the deadline would be on October 6 for us, October 8, dun sa isang class. Then, ayun na, we would have a ito yung required natin na synchronous session for next meeting. So, please encourage everyone to attend because, tama ba? Ay, hindi pa. Hindi pa pala. Bakit? Hindi pa pala, hindi required. Next week, October 11. So, ganito din. Kasi, in this week, magdi-discuss na, if I'm not mistaken, ng first law. Ano ba sa MetE 17? First law ata. First synchronous session natin, di ba? Ng first law sa MetE 17. Okay, so tama. So, sa October 11, this will be a synchronous, parang ganito din. It's not required. It would be recorded. So, we would just have a synchronous consultation for calculations ng first law at enthalpy. So, I'll be sharing some sample problems that we can solve. Tapos, announce ko na rin dito, yung mga nakalagay pala na homework doon ay exercises lang. So, you can do them on your own. No need to submit them. Yung quizzes lang natin. Sorry, MetE 17 na to ha. Yung nandun lang ay yung isa-score lang natin would be the quizzes. Tapos, ano pa? So, we would have for October 11. Yung first project consultation pala natin, ito yung required October 17. Tinignan ko kasi yung project submission. May nag-update. Kanina, wala to. Nasaan na ba tayo? So, ito, may nagsasubmit pa lang na 2 groups pa lang. Ito pala, magka-group ba sila? May group na ba to? Meron bang nag-a-attend dito? Wala. Katipay, wala no. Ayan, si Sereno. Ay, hindi rin. May group na. Baka sila na yung magka-group, no? Tapos sila na yung magka-group.
Ma'am, ano po, si Garcia Romero Bumanglag at Olivia po yung magkaka-group.
Okay. So, ito magkaka-group na to. Ito magkaka-group na. Okay. So, ayan. Given na yung groupings natin. Baka mas okay to. Leaning towards topic B for the first group kasi wala lang, baka okay din yung ma-produce nyo na topic. Tapos ito. So, effect of heat on battery life of modern gadgets. Effect of your future and experience heat. So, paano yung balak gawin to? Baka mahirapan ka. Parang ano ba to? Bakit mainit sa Cagayan? Tama ba? Ito yung mga questions na gusto ninyong sagutin. Bakit malamig sa
Since magkakalayo po kami ng group mates, ma'am. Then we can utilize that.
Sige, pwede yung tingnan yung parang transfer of heat mo. Pero medyo kinetics na yun. Observe increase in room temperature as caused by luminescent bulbs. Anong ibabari nyo dito sa letter C? Highlight ko na to ha. Parang, or sabihin ko na, so group 1, leaning towards B. Sa group 2, you can work on A and B. Not sure kung parang increase in room temperature as caused by luminescent bulb. So this is depending on the wattage. Tama ba? Kapag ganito,
Yes, ma'am.
you have to relate also kasi hindi lang wattage yung consideration when you choose luminescent bulbs. You also choose the area. Tapos, because pwede nyo rin tingnan yung, ano tawag dito? Kunwari, yung position niya, saan may bintana, saan may source of light. Mga ganong considerations if you do this. You can work on either A or B, but for B, siguro the challenge here is how well you can incorporate the thermodynamic concepts. Kasi sa A, definitely mas madaling i-apply. But ayun, interesting na rin yung sa letter topic B. Yung sa topic A, yun, yung sa group 1, yung sa topic A, wag na yung sa dogs. Hindi ko alam paano, kasi yung inisip ko is, how would you determine this? So based on need lang, as you would justify na yung dogs mas gusto nila sa ganito. Tama ba? Sino ba yung group 1? Si Dado. Ito pa, di ba? Ayan, sinabi ako. So, medyo baka okay si letter B na tingnan. Pero yun, kailangan yung maghanap ng parang data. Tapos, medyo related din dun sa B. So, your geographic location would also have a factor here. So, kunwari, yun yung isang pwede yung tingnan. Nandito sila sa ganitong area. Tapos, pwede yung tingnan yung region. Tapos, siguro, more of suggestions, di ba? If you know na ganito yung data during summer, what you can do. Serve mo application ulit yun. Ma'am, para saan nga po ulit yung required sync session? The required sync session, meron tayong 4. Ano ba? Wait, check ko ulit. Di ko memorize eh. Pero yung required na sync session, 4 yun eh. Yung kulay red. Ayan. Yung required, so yung una, tapos ito, yung short pitch of your project outline. So required yun. Tapos ito, i-require siya kasi asynchronous na lahat. So introduction of the experiments. Then, yung last na is yung project presentation. So we have 4. So tapos na tayo sa isa. Tapos ito, sa October 18, yung isa pa. Yan. So, yun lang yung required. Ito, I would open, yun nga, as I've mentioned, I would open this. Yung mga may parentheses is highly encouraged, but it's not required because I would be doing recordings naman. So, at least if you are free and if you have particular or burning questions about the topic, I encourage you to attend. Sige, nasalit ko na yun. Tapos, we think po, ma'am, na mahirap kumalat ng literature. Oo, medyo mahirap kumalat ng literature na for dogs. Kasi dogs yung tinitingnan nyo eh. Pwede yung tingnan in general yung heat ng mga surfaces. Yun yung pwedeng pivot ninyo. If you want to pursue for topic A, tapos material property siya. So, pwedeng ganun na lang instead of dogs in general. Kasi mahirap i-quantify eh. Pwedeng humans. Pwede bang humans? Wooden floor. Complete time. Pero may ano to, definitely there's an explanation here. Okay? I think wala na. Tama ba? Yun na. That's the last of my presentation. So, malinaw ba? Review lang natin ulit yung agenda natin today. Parang nilagay ko sa dulo. Oh no. Ay. Ako, ayaw lang mag-slide do. Doon ako laging na ano eh. Okay, nag-hang na naman yung PowerPoint. So, ganun pala siya nag-hang kapag binabalik ko siya doon sa slide doon na slide. So, anyway, may questions ba ba? You have any questions? Okay na ba tayo? So for Katipay, Morelos, yung group 3 and 4 natin. So I hope if you are listening sa recording na to, you can input your topics as well so that I can comment na. So if wala na kayong questions, we would have a non-required synchronous session for next meeting for some sample calculations. Kasi, yun nga, excuse me. So, sa syllabus map natin ay, yun na, yung susunod na worksheet, which is calculations for first law of thermodynamics at saka sa enthalpy. So, that will be on October 11. Mauuna tayo ng konti sa if I'm not mistaken. Okay, so pag wala ng questions, so I'll upload the recording here so that this can be watched by those na hindi naka-attend for today's session. So if wala ng question yung mga people in this room, I think that's it. Thank you for attending and have a nice week ahead. Bye-bye. See you sa mga mag-a-attend sa MetE, sa event team. See you on Wednesday. Tama ba? Wednesday ba tayo? Friday? Nakalimutan ko na.
Friday. Wednesday and Friday po, ma'am.
Okay. So, Friday lang. Sige, I'll send the calendar invite na lang. Bye-bye.
Thank you po, ma'am. Bye-bye
Thank
po.
you,
Have
ma'am.
a nice day.